Hey, what's up, guys? Mr. Fortin here. We are just pushing along through chapter 3, simplifying and solving. That's right, that's chapter 3. We're already up to problem 391. That's it. We only have one lesson left after today. Today's Tuesday. Wednesday, you'll be your last lesson of the chapter. And then we got a couple days to review and whatnot, coming up with your sub. And then you'll take a quiz on Tuesday with all the solving stuff we're doing. Exponents problems, multiplying using generic rectangle. Oh, yeah, all that good stuff. And most recently, what you're doing right now, which is solving equations, solving for particularly a variable. And solving is just one of those things. It's just one of those things that it takes practice. It takes doing it a lot. It takes seeing patterns here. It takes feeling it out about how I kind of undo something like this and solve for a particular specified variable. Here, this equation down here in 391 part A, y is already solved for, right? Y is by itself. Y equals, what it represents is negative 2 times by x plus 5. So it represents negative 2 times some other variable, add 5 to it. Anyways, it's all fun and good. It's all fun and games. We'll get to the answers today. So we're going to solve this one for x down here in a second. Anyways, just real quick here. I know a lot of people want to have notes and whatnot. So we have here for notes, I just got a little 2 notes down as you're going to work today on problems like this. 1 and 2. This goes for solving any equation. Not just the equations you saw yesterday in class, because the equations you saw yesterday in class were a little more complex. You had more than one variable, right? You had more than one variable, right? So say you had something in standard form, 3x minus 2y is equal to 20. How can you solve for y? How can you get it into y equals mx plus b form? So anyways, your problems yesterday were a little bit more complex because you had more than one variable. Okay, but these problems here, what they're going to have in common is that you got to solve for one of those variables, or at least come up with an expression that represents, that is equivalent, right? Is the same thing as that variable. So anyways, this goes for if we're going to solve it in letter D, you're going to get a number as an answer. Okay, and the other problems, I think letter C actually, in the other problems, you have more than one variable. Okay, letter D, you're going to get a number as a problem because here I only got Q, right? If I only have one variable in my problem, my answer is going to be a number. If I have more than one variable, like in parts A and C, here I got X, I got Y, my answer is going to be a longer expression. It's going to contain more than one variable in the answer, right? That variable is going to equal to numbers and variables and all this good stuff here. So anyways, the principles of this, of solving, remain the same. Kind of what you've been doing, hopefully since middle school, if not even practicing a little bit for this year. The things I'm going to have you keep in mind on this one here is what you're going to do is you got to collect. Okay, step 1 is always to double check. So what's the variable I got to solve for? Ask yourself, what's the variable I got to solve for? And it's all mentioned here. Solve for x, solve for p, solve for y, solve for q. You got to ask yourself, what's the variable that I'm trying to solve for? And then you need to collect that variable to one side of equals. Okay, to one side of equals. If you can't get that variable by itself, if that variable exists on both sides of the equation. Okay, so keep that in mind. Collect variables to one side of equals. That's what you're going to do first. Second thing is you're just going to do your solving stuff. And it just is practice, and you get better at it as you do it more. You're going to solve by doing the opposite, right? Doing the opposite of what you see in the problem, what you see is happening to the variable. You solve by doing the opposite of that. You do the opposite to both sides to keep the equation balanced, okay? You do the opposite. And my thing for you to remember this is you start away from that variable. Okay, what you're going to see in part A, I'll show you what I'm talking about here. Start away from the x because you got to solve for x here. Ready to get going? All right, let's get going. Part A right now. Part A, solve for x. We have y equals negative 2x plus 5. Okay. Step 1, collect variables to one side of equals. Okay. Well, I got to solve for x here. How many x's do I see in this problem? Well, I see x right here. So it looks like I got negative 2 x's. Do I have x's on the other side of the equals? Do I need to do any sort of collecting here, or my variable that I'm trying to solve for already collected to one side of equals? Okay, I only have this x here, so I'm good to go. I don't need to worry about collecting variables. That variable, well, I didn't say variables, collect that variable to one side of equals because I have the x right here. I'm going to solve this on the right side. I just want to see x. On the left side, I want to see all the other stuff, all the other garbage. I want to move over there so that I can figure out what x represents in terms of y, in terms of numbers. Okay, so that's what I'm going to do. Okay, step 1's already done on part A. Step 2, solve by doing the opposite. Start away from that variable. Well, it's looking here again at x. What's going to be away from x? What's going to be the first thing we're going to knock off here on the right side? Well, negative 2 gets multiplied to x. If you remember our PEMDAS rules, negative 2 will get multiplied to x, and then we got a 5 added afterwards. So what's further away from x? The negative 2? Well, no, that's touching x. It's right there. Negative 2 times by the x. We've got a 5 here. It's getting added to it. That's what we're going to get rid of first, okay? Solve by doing the opposite, starting away from that variable. I have a plus 5 here. What's going to get rid of plus 5? That's right, minus 5. Plus 5 minus 5. Well, 5 minus 5, well, that equals 0. We make a 0 here, okay? So sometimes I do this because I have an equal sign. I want to keep my equation balanced. Okay, remember y, which is over here, okay, y equals negative 2x plus 5, okay? So if I take away 5 from the right side, I have to take away 5 from the left side to keep my equation balanced, keep them equaling each other, okay? So I'm going to take away 5. Start by doing the opposite. Take away 5 from that side, take away 5 from this side, and I'm rewriting my equation in a valid form as y minus 5 is equal to negative 2x, okay? What am I going to do for solve for x right now? Well, hey, there's only one thing happening to x right now, and I'm going to do the opposite of that. This negative 2, it's touching the x in front. What does that really mean? Right? If I had like a 5 right here, that would be negative 2 and then parentheses 5. What does that mean? That means multiply, okay? So negative 2 times by x, I need to get rid of the timesing by negative 2. What's the opposite of timesing by negative 2? Dividing by negative 2. The opposite of multiplication is division. That's where your brain needs to go to get a problem like that here. It's all about practice. It's all about focusing hard on videos like these here, okay? I divide this side by negative 2. Well, what's to happen? My equation be balanced if I just divide that side by negative 2? No, I need to divide both sides by negative 2, and that's going to keep my equation equaling each other, and perfect. I'll get my answer done here, okay? Divide that side by negative 2, and hey, I got my answer. You can leave your answer as that. So negative 2 divided by negative 2, well, anything divided by itself is equal to 1. So here, instead of having negative 2x's left, we just have 1x. We're good to go. And then that equals y minus 5. Oops, that 5 looks a little funky. Over negative 2. I got my answer there. If you wanted to break up your terms a little bit over here, right, that's fair too. You can break up your terms. This negative 2 is dividing the whole y minus 5, so you could break it up this way. You could make this negative 1/2. That's the same thing as dividing by negative 2. Negative 1/2 y, and negative 5 divided by negative 2, well, two negatives dividing one another would become a positive, plus 2.5. Is equal to x. So there's maybe another way to write the answer. They're both valid, but I'm going to circle that one just to show you, what do I do with that negative 2 dividing? Well, you could divide it if you wanted to, but you don't have to. All right, part B here, solve for p. Hey, actually, this one here, I am not going to get a number as an answer. Why? Because I have m, I have p in the same problem. So I'm going to solve for p, but I'm going to get, like, m is going to be on the other side of this. Numbers are going to be on the other side of this. We got to figure out what p equals in terms of m, in terms of numbers that we have here. M is a different variable, right? P and m don't necessarily equal the same thing, right? They probably equal something different. Okay, so let's check this one out here. Let's go back to my solving steps. Collect variable to one side of equals. I got to solve for p. Let's find p in here. I got p right here. Is that the only p? Am I already collected to one side of equals? Yeah, there's no p on the other side of equals here. So we're good to go there. Now I need to solve by doing the opposite. Start away from that variable. And sure, I can just do that right now. So p's right here, well, it gets subtracted by m, it gets multiplied by negative 3, and then it gets 7 added to it. So you know what? You could start simplifying this by getting rid of that 7 that's there. Okay, and that's plus 7 right here. Okay, so that's what might be what I would do first. Again, I'm going to draw a little line down like this, just to remember I got different sides of an equation. I got my m over here, and I got my 7 minus 3 times the quantity p minus n on the other side here. So I'm going to take away 7 from both sides so that I start isolating. I try to get isolating means get it by itself. I want to get p by itself. Start isolating it, so I want to get rid of that negative 7. Sorry, positive 7 there, and I get rid of that by subtracting 7. Okay, so then on the other side, I'm rewriting this equation. This is m minus 7, and that's equal to negative 3 times by p minus m. Okay, what can I do next? Well, your brain might be like, well, I've just practiced the distributive property of a multiplication over addition and subtraction, but distributive property, you have to do it here? Not necessarily. You could actually, what you could do right here, yeah, why not? Let's do it this way. Let's do it this way. There are multiple ways you can do this one. You might be solving by doing the opposite, because that's what I'm telling you. Start away from that variable. Well, the p's here. Okay, so what's closer to p, the m or the negative 3? Well, p gets subtracted by m first, and then gets multiplied by negative 3 afterwards. So the negative 3 is what you get rid of next. start away from the variable. P's here, and -3 is further from the variable than m is right here. Okay, so what can I do to get rid of the -3? Well, the distributive property tells me that -3, it multiplies to all this. Okay, so what gets rid of multiplication? Opposite of multiplication is division. Okay, I'm going to divide both sides by -3. And this becomes a little bit messy, but that's okay. Messy yet elegant, right? I got, well, this is m divided by a negative, so this will be negative m over 3. And here we have a negative divided by negative, so it's going to become positive, okay? Negative m over 3 plus 7 over 3, this is pretty messy, okay, is equal to, well, that -3 got canceled out by dividing by -3. -3 times this, divided by -3, well, multiplying by -3, and then dividing by -3 just cancels itself out. It becomes equal to 1, okay? Equals P minus M. Okay, I have to solve for P. I'm not quite isolated yet on this right side, so what am I going to do? I'm going to solve by doing the opposite. If I'm subtracting P from M, I can add P to this right side as long as I add M to the right side, as long as I add M to the left side, my equation remains balanced. I got heavier here, I'm going to get heavier as well on the other side. We're equal to each other, okay? And that will allow me to arrive at my answer, okay, which is going to be P is equal to, okay, ooh, this is a little bit tough here. This is negative, so what we had over here was negative 1m over 3. So I got 1/3 of an m, and I'm adding a whole m to that, okay? I'm adding a whole m. So if I have negative 1/3 and I add 1 to it, okay, negative 1/3, and 1 is actually would be equal in terms of 1 over 1 would be equal to 3 over 3, right? 3 over 3. So anyways, negative 1/3 plus 3 over 3, right? It's a little bit hard to do in your head, but negative 1 plus 3 would be 2, right? I don't know. Fractions are tough here. It's tough for me to review them too after so many years of math you guys have had here. But anyways, hopefully you see it. Negative 1/3 plus 1 would equal positive 2/3. So I'd have 2/3, 2 over 3 m. Okay, and then this was 7 over 3. I didn't actually do the fraction part earlier. Okay, plus 7 over 3. Okay, is equal to P. And that's my answer. Hopefully I got my answer right there, too. I haven't checked my answer key. I know I've had some problems with that, okay? Part C, solve for y, okay? Let's go back to our principles here. I'll do the rest of them kind of more quickly here. The first few examples go slowly because it's the first time I talk about the steps to think of. Then I go a little faster so you guys get practicing, okay? Step 1, collect variable to one side of equals. I got to solve for y. Good. I don't have to worry about that on this one because I got y over here. Okay, I got y over here. I don't have y on the other side. I've collected the variable I'm looking to solve for to one side of equals. It's already done for. It's already collected. Okay, so now I got to solve by doing the opposite. Okay, what I can do is, hey, you know, I think this problem is actually asking you to do more than this because you can simplify your answer a little bit here. Anyways, I'm getting ahead of myself. You might be thinking what I got to do is subtract the x squared from both sides. Sure, you can do that. What I'm going to do first is I'm actually going to multiply over here. Why? Because the x squareds are actually going to cancel out. They will in a second. Bear with me for a second here. Practice this. Check it out here. I got here a generic rectangle, right? Tell me about this generic rectangle. What's the area of this generic rectangle? Well, its length is x plus 6. Its height is x minus 2, okay? Because this mathematically, what we're seeing right here is x plus 6 times by x minus 2. Base times by height. Length times by width. X plus 6 times x minus 2. What does it equal as a sum? Well, I'm going to change it to that here because I noticed I had an x squared over here. And here I don't see an x squared, but I'm going to see an x squared in a second. Just bear with me right here. Okay, so anyways, the sort of the purpose of this problem, I can tell, is that it wants you to use a generic rectangle. It just does. It's screaming out for it here. So remember, generic rectangle, set it up. Okay, area as a product, it's already written out like this. Okay, height, x plus 6, width, x minus 2. Okay, x times by 6, well, that's just 6x. X times by x, that's x squared. Okay, this little part of the rectangle here, this little mini rectangle right here, its width is -2, its height is 6. So what's its area? Well, -2 times by 6, well, that's -12. Okay, and then x times by -2, that's -2x. Okay, I got my product on the outside, I got my sum inside, so on the inside here. So my sum is equal to the product, right? Area as a sum is equivalent. It's the same thing as area as a product here. That's one of the big things of Algebra 1 is going between these two forms, right? These algebraic forms here. X plus 6 times x minus 2. What's an equivalent way we can write that? Well, we can write it as the sum as you see here. X squared plus 6x minus 2x. Well, that would combine like terms. Well, I got 6x's. I took 2x's away from that. 6 x's, take 2 x's away. Oh, 4 x's, okay? That's what I have here in terms of the sum. And then finally, negative 12 ones over here, okay? So I'm doing that because what I noticed right here, right now, is that I have an x squared on this side of equals, and I have an x squared on that side of equals. So what can I do? Well, whenever you have the same thing on both sides of an equation, what can you do? You can just subtract both of them. They can just blast. They can go away as we simplify this one. Remember, the Untitled Chapter is simplifying and solving, okay? You got to be able to simplify in order to solve sometimes here, okay? So let's just simplify our answer a bit here. X squared minus x squared, well, that makes it 0. X squared minus x squared, I did that on both sides to keep my equation balanced. Oh, they just equal zeros there. I got rid of them. I'm going to have a much more elegant answer here because I did this generic rectangle thing, okay? So I got 4y. That equals 4x minus 12. Okay, what does the problem ask me to do? Again, solve for y. So maybe write this. This will be a linear equation. We're going to get this in y equals mx plus b form. Check that out. Okay, what do I got to do to both sides now? Divide both sides by 4. Okay, 4 is, we're solving by doing the opposite again. Okay, 4 is being multiplied to the y. What's the opposite of multiplication? Division. Okay, 4 divided by 4, that's 1. Okay, I can divide the whole side, right? Remember, dividing one side by 4, I divide the whole other side by 4. So I'm not just dividing the 4x by 4. I'm dividing the 4x and I'm dividing the negative 12 by 4. Okay? So what that's going to simplify to is 4x divided by 4. Well, that's just 1x. Negative 12 divided by 4. Well, 12 divided by 4 is 3, of course. So if the negative 12 were negative, I'd just be negative 3. And there it is. Look what an elegant answer that is right here, okay? I've solved for y. I've isolated y. I've figured out an expression that y is equivalent to, okay? We're going to do the same thing over here, but we're not going to have x and y. We're going to have q and, well, it's just going to be q, okay? So this is nice, right? It's nice when you have an equation where you're solving for a variable, but that's the only variable in the problem. In that situation, your answer is going to be just a number. Like, it's not going to be any other letters or something like that, right? So solve for q. Okay, let's go through again my solving principles. Collect variables to one side of equals. Well, I got them on both sides here, okay? One thing that I might do first is the distributive property here because I got to figure out which side I'm going to collect to. So here I got 7 q's over here. Here I'm going to have 4 q's, okay? And I'm going to go ahead and I'm going to distribute here. Remember, distribute. So if I see a number on the outside of parentheses, what does it do? It multiplies to each of the terms on the inside of parentheses here, okay? So I'm going to get 4 times by q minus 8 times by 4. And 8 times by 4 is 32, okay? Hopefully you should do that in your head, right? You should know your multiplication tables and whatnot. If not, you got your calculator out, right? You just have to, calculator is an extension of your arm in math class here, okay? Because we got to move. We got to move through this harder stuff here, okay? So now collecting, so I distribute that there. It's going to make it easier for me to figure out how I can collect because I'm going to collect the side that has more q's on it, okay? That's going to keep my q's positive, okay? So I have more q's over here, 7 q's. So what am I doing with that right here, this 4 q's? Well, I need to get rid of the 4 q's on this side so I can start isolating the q's on this side. Okay, what do? I subtract 4q from both sides because that's going to get rid. I'm going to collect all the q's I have to the right side here. I got 4 q's over here. I got 7 q's over here. I'm going to take away all the 4 q's there. I'm going to take away 4 q's there, leaving 3 q's over here. Okay, but this made a 0, so I need to show it here. Okay, now I got negative 32, and that equals 3q plus 5. Keep solving this one here. What's my principle number 2? I collected variables to one side of equals. I solve by doing the opposite. Okay, start away from that variable. So I can either do the opposite of multiplying by 3, which would be dividing by 3, or I can do the opposite of adding 5, which is subtracting 5. Which am I going to do first? Well, the 5 is further away from the q. This 3 is touching, it's kissing that q right there. It's multiplying to it. This 5 comes in afterwards, right? We add 5 to whatever 3 times q is, so we're going to get rid of the 5 first. And that's easier. Adding 5, what gets rid of adding 5? Well, subtracting 5, doing the opposite, okay? Subtract 5 here, and what I get is negative 37 is equal to 3q. And finally, last but certainly not least, I divide by 3. Divide by 3. Okay, negative 37 divided by 3. Can we simplify that? 3 goes into negative 36, right? How many times does 3 go into 36? 12 times, right? So this would be negative 12 and 1/3, right? Because 37, right? 1/3 more. I don't know. Anyways, the remainder be 12. 12 and the remainder of 1 would go into 37. Remainder of 1, we'll divide that by 3, which would be 1/3. Anyways, we get that equal to q. And hopefully I got this all right because I put my heart and soul into this video lesson that we have right here. So let me just check my answers here. I get the fancy Ooh, what are we looking at here? We're looking at the glossary. Oh, that's coming up in my next video. Look at the answer key here. Yeah. Oh, I got the answer key right here. Let's check it out. I got that one right. Let's see. I got this one. Yes, I did. And yeah, I ran the table. I got them all right here. I feel good about that. Okay. Message me if you have any questions. We'll get more practice on this in tomorrow's class. Will be the last lesson of chapter 3. And then you'll definitely have a review worksheet, if not 1 day, 2 days before the quiz. Okay. Message me if you have any questions. Thank you for watching. Bye.